Okay, so I did a video earlier where I tried to live stream the opening of my Creation Crate projects that just came in the mail. But I wasn't actually able to do anything because I had to watch a bunch of videos. And so now I have watched the videos. I have had a recap of high school physics, and I now have the instructions to sort of build a circuit to get like to write a simple Arduino program and to get an LED lit up with my circuit and with various components. So I'm going to try and do that on video. I have not done this before, so if this fails miserably, you get to watch it and enjoy watching me sort of struggle with this. But yeah, I'm just kind of going to read the instructions and go through and hopefully not make any mistakes. So I have here in front of me a breadboard, which is this cool way to not solder things together but still be able to make little toy circuits. And I have what's been referred to in videos as an Uno something. I don't know. I think this is the Arduino thing. And I assume that Uno and Arduino sounding similar is not a coincidence. But in any case, I don't really know. And so my first instruction is that I need to connect a jumper wire from ground on the Uno R3 to the blue rail of the breadboard. And that's like a negative part of the breadboard apparently. So, okay, so I'm going to, I have all of these, this large set of jumper wires. And so watch me struggle with this. Ugh. I think this is electrical tape. It's kind of hard to get off. Okay, I got it off. I have a whole bunch of jumper cables and they're all different colors and that makes me happy. So I will pick a random, well, I picked two by accident. Did I? Is this meant to be like this? This looks wrong. I'm going to pick a different one. That actually might be something else that's meant for a different purpose. Maybe it's not a jumper wire. Okay, this looks like a jumper wire. It has two ends that look the same. And so now I'm going to do the thing it says. On this, there's this little section called power. And two of the things say G and D, which is ground. So what I have to do now is I have to connect ground to J5 on the breadboard. And J5 is over here. Wait, is that right? No, that's not right. To the top blue rail of the breadboard, never mind. Right, so I can kind of just put it anywhere. So I'm going to put it here because I want to. And I assume this works. We don't really have a way of knowing until the whole circuit is connected. So we're just going to go with that. And then I need to connect another jumper wire from the blue rail to J5 on the breadboard. And so I've got my second jumper wire. And I'm going to go from anywhere on the blue rail to J5, and these the horizontal, well, yeah, I guess they're rows even from your perspective. The rows have letters on them in the middle, other than the plus and the minus that are just kind of like on top. And they said some stuff about how the charge alternates on rows. So if this is negative, then this is positive, and then negative and positive and so on. But along a column, if you connect it, it becomes the same. And so along a column, like if I were to now connect something, since I've connected negative to J5, if I were to now put something else in 5 in that column, then that would also be negative. And I believe that's what happens in the next step. So let's see, let's continue. Now they want me to add a resistor and an LED. And 5 volts is too much for the LED, so that's why we need the resistor, because 5 volts is the setting that my Uno R3 is going to give me. And so I believe I have to start by adding the resistor, so I have to take it out of the thing. Let's see. Okay, I have my little resistor here. It's small and cute. And I don't really know if there's a specific direction that this resistor is supposed to go in, but I'm just going to copy what it says on what it has on the picture, which has the red. So you see how there's little colored lines on it that go around the resistor. So the red one's supposed to be on the right in the picture, so I'm just kind of going to follow that. And it wants me to connect the resistor from I5 to I10. And so I think that I need to sort of bend this wire a little bit to do that. So I5 is in the same column as this jumper wire, so it's going to have the negative charge. And where does it want me to connect it to? I10. Oh, okay. Well, I suppose I just have to bend this quite a bit, huh? So I5... I10. Okay, I really got it. I've lodged it in there now. So now I have a resistor that's part of my breadboard. It's going from I5 to I10, so it's continuing that negative charge over there. And now I have to bring my LED out. So I'm going to get my red LED out. There's a bunch in this kit for the next project. But here is my red LED. It has these 2 leads, and the long one is, I believe, the positive side, and the short one is, which is on top, is the negative end. And so what I want to do is I want to connect the negative end, i.e. the short end, to sort of continue the circuit here. So what it's telling me to do is it's telling me to connect the short leg of the LED, which is the cathode, the negative end, to H10, which is just one row down, but the same column as where this resistor ends. And the long leg to H15. And so I'm attempting to do that. Sometimes I feel like even though I have small hands, my fingers just aren't delicate enough to do things like this. But it's still fun and it doesn't stop me. Okay, so I have now got my LED nice and lodged in from H10 to H15. And so that negative charge, the negative current's going to kind of flow down through column 10 and then go through to the LED and then continue to H15. And then now I assume we're just going to kind of continue forward. So let's go to the next step. Now we need to complete the circuit. Remember, a circuit where the current cannot flow from positive to negative is considered open and will not work. So you have to close the circuit for electricity to flow. And so I suppose that's what we're going to do now. We're going to take another jumper wire. Are there any other colors? Yeah, okay. So I'm going to get a red jumper wire this time. I think I've used only black ones so far. And I'm going to connect the bottom red rail. Oh, wait, really? Oh, interesting. Okay, so it wants me to like connect this bit to the bottom red rail and then kind of go around that way. I don't think that's actually necessary. Well, I'm not going to question the instructions. What do I know? All right, so connect a jumper wire from F15 to the bottom. So F is the same, 15 is the same column as my LED kind of goes out to. And F is just like 2 rows down from there. So I'm going to stick that in, and then it wants me to connect it to the bottom red rail, which is positive. I mean, truly, I think it would also work if I just went to this positive rail instead. But I will follow the instructions because I'm just like that. And then I'm going to connect another jumper wire from the bottom red rail to the pin on my Uno that says 5 volts. It's right next to the ground one that I plugged into. And that is going to complete the circuit. However, nothing's actually going to happen because this doesn't just give me current. This is not like a battery. It has to be plugged in. So my jumper wire is not incredibly long. So let's kind of... Well, I suppose I can just do it from here. So yeah, that's definitely the positive end. And I am sticking it into 5 volts. And I believe I have got that right. Okay, so that is, I think, a complete circuit. I want to... So the next step it says is plug in your microcontroller and watch it light up. But I want to just check that I've got this right. So I have my current that's going to flow from positive to negative because that's how current flows. So it's going to go from this 5 volt thing to this orange jumper wire. It goes into this red bar at the bottom of my breadboard, which is positive. And so it kind of just flows all through here, and then it goes into this jumper wire, the red one, and then flows through to F15. So now 15, this whole thing is sort of... current is sort of flowing through it. And so at H15, which is where I have my LED plugged in, it goes through the LED, and then it comes out at H10. And then again, column 10, it sort of flows through and sort of gets into the resistor at I10. And then it goes through the resistor, and then it goes to it goes to I5. I don't know if I said I10 before. It goes to I5 after going through the resistor. Then J5 goes to this negative blue bar at the top, which is then connected back to the ground with the Uno R3. So I think this should work. This seems to make sense to me. So now I just have to like plug this in and hope for the best. If it doesn't, my connections are probably loose somewhere. Oh my gosh, look, it worked. Not only is my Uno R3 on, but I also got my LED to light up. That's fantastic. Yay, it worked. Great. Okay, now I have to, I think at some stage I have to do some programming. So let's see what the instructions say. I've not looked at the rest of these instructions either. Once you're done, you'll have a closed circuit because there are connections being made inside the breadboard. Here's how a breadboard makes those connections, blah, blah. Okay, it's just explaining everything that I already knew from watching the previous videos. So that is fine. And now, this is a challenge. Place a second LED in this circuit and make it light up too. Hint, you don't need any additional wires. Just think about how the columns on the breadboard are connected internally. Okay, so I'll do that. Let me get a blue LED this time. And I remember that the long one is positive and the short one is negative. So I might actually unplug before doing anything that might sort of be bad. Okay, so let's see. So I have my current sort of flowing through various things. This should be fairly easy to figure out. My current is flowing this way and then going out that way. So I suppose really kind of anywhere here, I think it should work for me to just kind of add it in parallel to this other LED. And so I want to go positive to negative. And so the long one is positive. So I'm going to put that in 15. And this is, by the way, this is J15. And then I'm going to connect it to J10. And so I don't have to do it this way, but this is, honestly, this is the only place that I have space to do it because everything is pretty tightly put together on this side. Well, actually, yeah, no, I do have to do that because that's where I have a place to kind of get out. So... oh dear, this is a challenge for my fingers. I wonder if I should just bend it first. I bet kids like this more than I bet kids find this easier because they have smaller hands. Why do I get the feeling that as long as I play with this kit, you're going to be hearing about my hand complaints? Okay, so I think that should work. I think I managed to stick my LED in from J15 to J10. That's positive to negative. And so my current's going to flow 5 volts to orange, orange to red. And from red, it's going to sort of have this whole thing, the whole of column 15. And then on both row H and on row J, it's going to go from 15 to 10 through both LEDs. And then it's going to sort of go through the resistor because all of column 10 is kind of connected and has the same charge. And then it's going to sort of go out through the same path that I described earlier. So I think this should work. I think I should get 2 LEDs. Let's hope and pray for me. Damn it, that didn't work. Okay, wait, why does that not work? Have I just not pushed it in hard enough? Seems pushed in. Should I move things around? Maybe I need to move things around. Maybe that's my issue. Okay, so I suppose if I moved this here, it doesn't make a difference. And if I were to move this here, it also wouldn't make a difference. And then if I were to connect them serially instead of trying to do this parallel thing that I'm trying, I think that should work. Okay, so I'm gonna unplug this for a sec. And what I have to make sure is that what I have to make sure is basically that the circuit is complete. So let me give myself enough place to do this. So let's say that I'm going from F15, or rather that I'm going from F20 to F15, right? So I'm gonna stick my LED in this way. And so the plan is that this is going to work by, no, I should put it in G. Yeah, let's try that. The plan is basically to connect them serially instead of in parallel, which is what I tried earlier. I'm not entirely sure why that didn't work. I feel like maybe I need to revisit physics. This is actually so fun. I kind of wish that this was how I learned these things in school. Okay. Let's try this again. Okay, that feels a little bit better. No, it doesn't. Wow, this is extremely finicky. I wonder if I should, like, get my pliers or something. Just to, like, help me with the wires, because they're getting kind of bendy at this point, and I think that makes them harder to work with. Okay, that felt good, how much that went in. And I just have to make this one go in that much as well. Getting the... Why I'm choosing to do 5-point increments, I don't know. No good reason. Okay, so now I think this will work. So basically the plan is my current will flow from 5 through the orange, go down here, go through the red. Now in 20, it will sort of go into the blue LED, and it will go out at column 15, where the red LED is also connected. So then it will go straight through the blue LED, then it will go through the red LED, then it will go through the resistor, then it will go out to ground. So I think this should work. If this doesn't work, I truly am at a loss. Okay, there. It worked. Great. I got it to work. Fantastic. Look at that. Look at me killing it. Complete and continue. I completed building the circuit. Fantastic. Okay. So there's now a video for me to watch. So I think this seems like a good place to pause my recording and then kind of see where to go from here. I might watch all the videos that I have to watch and then come back to code. I also feel like I need to figure out exactly how I'm going to do the recording of the code, because I feel like I kind of want a video of me going at the same time as you see my code. I don't know if that's necessary. Maybe that's not necessary. Maybe I'm overthinking that. We'll see. Anyway, see you on the other side. This feels like it's already been quite productive because I got 2 LEDs hooked up and I did electronics. I did an electronics and I'm very proud of myself. All right, see you on the other side. So I was done with part 1, which was the part where I didn't have to write any code. I just sort of set up my circuit and it is here, still here. I have changed it to be the original version where there was only 1 LED instead of 2. So that's what I'm going to use now for the next project. And that, or well, rather the next part of the project. And that is to write code that is going to turn my LED on instead of just plugging it in to a power source. So the first thing I'm going to do is I'm going to switch out where it's getting the sort of current from. So instead of giving it like a 5-volt power source, I'm going to plug it, I've been told to plug it into this number 7, and I think it's like a port or something. A digital pin, it says in the instructions over there. So I'm going to connect it to digital pin 7. And I'm okay with that because 7 is a prime number and I like prime numbers. And now it wants me to basically like write this code out. And this is supposed to be, I think, Arduino code. It tells you to do it in the Arduino graphical user interface. So it makes you like download an application, but I don't really want to do that. I want to make it interesting. And so I installed the command line version of Arduino. So Arduino has like a command line thing, which is, which is over here. And I installed it and I tried a bunch of things to get it to show me what it's supposed to show me as the output of this command, but that doesn't seem to be working. So I mean, I think I'm gonna have to just specify it myself based on what I know and debug the rest of this later. So I haven't actually tried this yet with the command line, so there's stuff that I don't really know how it works, so that'll be fun to figure out. But essentially the as far as I can tell, the flow of how this works is you have your program that you write, which is like a .ini file, and then you compile it, and I think there's like an Arduino CLI compile command or something like that, or maybe it's verify. And then you have to sort of upload it to your device, which makes sense since it's like a hardware thing. And to do that, you need to say what port it's on and the fully qualified board name. Now, I think what's happening here is that so I'm not 100% sure why this is unknown. I tried to install and update a bunch of things and that doesn't seem to be working, so I don't know if it's like a missing, I don't think it's a missing driver because the Arduino application knows what's going on. So I will bother about that later, but I think it should work if I just use Arduino AVR Uno, which is supposed to be the fully qualified board name of my board, because this thing over here is an Arduino Uno. And I know that it's AVR because I cheated and I looked inside the in the Arduino like application in the sort of folder that they have for the application. They have a bunch of things, including the fact that this is an AVR architecture. And so I think the all that's left for me to do right now is basically just figure out how I'm going to write the code. And so I think, right, okay, so I think how it works is you have to like write a new sketch, and I don't know why. I mean, I don't really see what's stopping me from just using Vim to write a new file that ends in an INO extension, but I mean, in any case, let's just do it that way for now and then see what happens later. So Arduino sketch, new. That sounds about right. Ugh, what do I have to do now? Oh, okay, I have to give it a... right, so this by the way, the program that I'm going to write is something that is going to make the LED blink. And so right now it is not, it's not blinking. In fact, as soon as I took it away from the power source, the LED actually went off. So it's not actually doing anything. I mean, if I were to plug the power source back in, it would turn on. And as soon as I put it in port 7, it stays off. And so what I'm going to do is I'm going to write code that tells it to wait for like 1 second and turn it on, and then wait for 1 second and turn it off, and kind of just do that forever. Okay, so I'm going to call it, I'm just going to call it Blinker. And okay, so it created the thing. Oh, why does it have to do that? That's odd. If that was all that it was going to do, I could have just typed that out myself. Okay, well, I don't like that. I'm not going to do that. I am just going to write a blinker.ino file. And what I'm going to do is, so apparently all of these files are supposed to have 2 functions that are important, that are somehow special to Arduinos, and one is the setup function and then the other is the loop function. And so anyway, we'll figure out if I can sort of do more interesting things with this afterwards, but for now I think the first thing I'm gonna do is I'm gonna, oh actually I suppose I don't have to, well, in any case, pin mode 7 and then output for whatever reason. I think output might be special, so I'm just going to go with that. And then I'm just going to turn it on for now. And I believe that is with high. And so I have at this point just hard-coded the pin ID because it's 7. And I think in their code, if you look at their code over here, you'll see that they have used a variable, and honestly, it doesn't really matter. So I think that should work. And I believe now I have to sort of, I'm gonna clear my screen. I have to like verify it or compile it or something like that. Is compile a thing? Ugh. Oh, I see. Oh, so it has to have the same name as the folder that it's in. Okay, interesting. Well, that, really, that's kind of frustrating. There's no other way to do it, huh? And I think Sketch didn't have any other options either. That's pretty sad. Okay, well, what if I were to move Blinker to, whoops, getting started.ino? One thing that makes this a little bit annoying is that I have my mic, which is like right in front of my screen, so I can't really see the bottom of my screen. I should probably change that for next time. Right, okay, and it doesn't compile apparently unless I give it the FQBN, the fully qualified board name, which, as I recall, was something like Arduino AVR Uno, I believe. And yeah, okay, so that worked. It compiled, that's good. And now what I want to do is I think I want to upload an Arduino sketch. And so if I just sort of switch that out to upload, that's still going to complain because I think it wants a port. Right, so I now have to do, there's something that I did, list boards or something like, no, that's not it. Let's just look at the help. Right, Arduino board list, maybe. Arduino CLI board list, was it? Yeah, there we go. Okay, so this port, the USB serial 14330 is the one that corresponds to my Arduino. The one that's right above that, the Bluetooth incoming port, I have a bunch of things that are plugged in, but I have a feeling that that's for my mouse, which is a Bluetooth thing that needs like a USB thing stuck in. So I have a feeling that that's what that one is. So I think that this command where I'm trying to upload things should work if I just specify that as the port. And ooh, see that? It just lit up. That's great. So it worked. And now I think if I wanted to turn it off, I could just go to my INO file, and then I could just be like, I could change high to low. And then if I actually so I would still need to compile it because it says compile. And then I can upload it. I guess my question is, when it compiles, what actually happens? Does anything happen? Seems like there's nothing here. So I wonder if the compile step is actually necessary. Oh, and by the way, I forgot to point out that my LED went off. So that's cool. Okay. Now I guess I should do the thing that they actually asked me to do in the project, which is to make it go on and off forever. And so let's say I'm gonna turn it to high, I'm gonna delay for like that long, and then I'm going to do sort of the same thing again, except this time I'm going to turn it off and then wait for a second. So I think this should work. 7 is hard-coded everywhere. That's fine. I will fix that later. It also doesn't really matter anyway. And so gonna clear my screen and compile. And then what was it? It was upload, wasn't it? Yeah. So pay attention to the LED. Let's see what happens. Yeah, so it turns on for like a second and it blinks. I love it. Wow. I feel amazing. I feel like I've done something so cool. Okay. Well, what should I do next? I guess I can... okay, so one thing I will do is I will change this code so that I'm actually, not hard coding the variable. So let's say, okay, let's use LED 1 because maybe I want to try and mess around with 2 LEDs. So that might be fun. So I'm gonna set LED 1 to 7, and then I will just use that as my, I could replace this more efficiently, but I haven't. Now I think that should just work. Now, how will we know whether this actually worked? Well, I think it will fail to compile, and it will also probably fail to upload or work properly if something bad happened, but it seems to still be working, so I think that just was fine. And now maybe the next thing I can fuck around with is switch it to... I guess I maybe shouldn't do this because I don't know if the definition of high and low changes depending on which pin you put it in. Because I think the implication here is that high is 5 volts, but I don't know if high is 5 volts everywhere or if it's specifically 5 volts for digital pin 7. Am I willing to try it out and risk losing an LED? Maybe. I will try, let's try 5. Just because I feel like it. Now, yeah, okay, so the compilation will work because it's for a specific board type. Now, if I try to upload it, this should not, first of all, it shouldn't do anything because my thing is not plugged in and my thing is gone, my LED has gone off as well. Now, I wonder what happens if I just put it in, was it 5? I think it was 5 that I had picked. If I put it in 5, does it start? Oh, it does. Wow, that's pretty interesting. So I guess it just keeps sending the signal, and then when you plug it in, it just kind of works. That is pretty fascinating. Okay, well, I'm wondering now if I should just try adding a second LED to this, just for funsies. Okay, great. This is the LED that I've just completely fucking destroyed. But you know, let's go with it. So I still haven't answered my question that I had earlier, which was why was it that when I tried to connect them in parallel, it did not work? And I still don't have an answer to that. So that is that. Okay, so now the circuit's broken because I just took this out. And what I'm going to do now is I'm going to make the circuit complete again, but this time I'm going to do it with my blue LED. And the longer side was the positive side, and so that is what I want to put in column 20. And let's hope and pray that this isn't as painful as it was last time. And then my negative side should go into column 15, so it completes the circuit there and joins the red LED. Ugh, God, this is a struggle. Okay, things are happening. Oh, well, that's interesting. I suppose since it completes the same circuit, I don't yet have a way of isolating it unless I make an entirely different circuit with it. I wonder if I should do that. Maybe I should stop this video and film a new one where I try that. And I try building like a brand new circuit. And then with my new circuit, I can probably try and isolate so I have different pins going to different LEDs. Although maybe I'm getting ahead of myself. Maybe I should just do project 1 and then see what happens. Okay, test plus challenge. What is this? On and off, back and forth. Yeah, I don't think it's saying very much. It's just 30 seconds. Okay. Place a second LED. Oh, that was the challenge question. Place a second LED in this circuit and make it blink alternately. Oh, the new LED will need to be connected to a different pin on the Uno. Oh, so it wants me to do this as a challenge thing. That's great. I can do that. All right. Well, in that case, let's get on with it. So let's get some wires. What are these called? Jump jacks? Why do I not remember these things? Somewhere over here. Jumper wires. I see. Okay, jumper wires. There we go. Hopefully I remember that for next time. All right, so I just have to find a wire that actually works. Maybe I will turn off screen recording for this part and then just focus on like a video. All right, so I left off in the previous thing where I sort of have my circuit set up. There is one pin number 5, that is connected to the circuit that also is connected to 2 LEDs, and so they're blinking alternately because that's the code that I had it run. And so now what I want to do is I want to add a new circuit that sort of is, I think, connected to a different pin. And so then I can sort of control both the LEDs separately, and so this will be fun. Let's see. I will connect pin number 3 over here. I think that should be fine. I will just have 2. Will that work? No, maybe I should go to the other one. So maybe what I should do instead is I'll pick this other plus thing, which I haven't used yet, and I'll try and use that. Yeah, I feel like that maybe makes some more sense. I'm not sure if that's how they want me to do it, but you know, we'll figure it out. Now I feel like I need some more because I need... Oh, you know what? I don't know if this will work because I'm supposed to use the same resistor. I wonder if this is where I need to do my parallel thing, which didn't work earlier. So let's see. Let's take you out. Let's try and put you in parallel here. Right? And let's do this. Now, for whatever reason, this just doesn't work. And I am not entirely sure why. But if I were to, well, okay, so not this one. But if I were to do something like this, are you not going in? Oh, is that? No, that's not a good idea. I should probably put this somewhere slightly different. How would this work? What if okay, right. So maybe what I can do is I need the out. I need both of them, both the LEDs to go out and through the resistor. But things don't need to come into them. Like current doesn't need to come into them from the same place. So if I switch this from 15 to 16, even though it's a pain to do that. And then I would, like, let's just say that I'm going to use the 5 volts just to see if the circuit works at all. And then if I do this, there we go. Okay, now that works. But again, for whatever reason, I seem to be getting this alternate signal. And so I wonder how we fix that. I feel like maybe if I stick it in 3 and then kind of program 3 differently, that could work. Okay. So, yeah, okay. So I think this works so far because earlier what I had was I just had a connection from 5 volts to the LED and then it kind of continued. And the reason that it made the circuit complete was because I was just giving it a power source. But now, instead of giving it a power source, I'm actually connecting it to a pin. And so I have to tell things at the, I have to write code that works at the pin level to be like, hey, this is what you're supposed to do. And so, okay, so now let me just switch to screen recording so that I can show you the code that I'm going to write. We're back at this place where we have from the original project, we have pin 5 that's sort of connected to this red LED directly with this conveniently colored red wire. And now I have this blue thing that was connected in parallel. I was wondering why that didn't work earlier. And I still don't have an answer to that. Oh, I wonder if it's just like, right, because it just like had to go through the first part that it got, and that was the red LED and not the blue one. Okay, well, that's a theory. So anyway, so I have a power source connected from pin, looks like I plugged it into 2 this time. And so that is connected to the blue LED. And so the blue LED can work if I give it instructions to work. And so what I'm going to do is I'm going to open up my INO file again. And I'm going to sort of specify my LED 2 that is stuck into pin, whatever it's called. And here what I'm going to do is I'm basically going to alternate these. So I'm going to call that, I'm going to say LED 2 should be low when LED 1 is high, and LED 2 should be high when LED 1 is low. And I mean, I really think that that's it. This should compile and then it should just work. So look at the board and see what happens. Oh, look, it works. Oh my gosh, this is amazing. Wow, I really feel so cool right now. I really wish that I'd had stuff like this in school. I honestly feel like spending a couple hours on this today. Well, I don't want to say I'm never going to forget because I've said that about things before and completely forgotten. But I feel like it is a lot more memorable to learn like this by actually doing. Anyway, so I guess that means that I'm done with this little mini intro course and I can just kind of start. Oh, wait, there's more. Circuit modifications, blah, blah, make it. Oh, is it just telling me how to do that then? Remove the jumper wire connected to the 5V pin on the Uno. Move it to pin 7 on the Uno and F15 on the breadboard. Am I not done with this? I did. Yeah, okay, so I guess they were just telling us how to do it. So I completed the bonus intro course, Let There Be Light. And so now I can start with the official first course, since this was just part of like the getting started thing. But what I'm going to do is I'm going to commit, well, I'm going to commit this code to my branch. Right, it's untracked. That seems decent. I don't think that I need to, well, maybe I will write one comment to say what this is actually doing. This is alternating blinking lights with 2 LEDs. And so now I'm just going to add that and commit, and I am done with the getting started thing. And yeah. There we go.